Hello. Hello.
Good evening.
Yeah. Good evening. Okay. So today I want to do finish this conic sections thing. So parabola, ellipse, and all hyperbola. So let's try and understand what these are and how.
No. Sorry, I was showing my dad. Sorry.
Uh, let's try to understand what is happening here. So basically, so far we have seen circle, and we have understood that circle is locus of a point that moves in such a way that it is equidistant from a fixed point, right?
Yeah.
Equidistant from a fixed point. Your fixed point is the center, and the distance that is equidistant is the radius, and that locus gives you a circle. Now we'll think about slightly different types of locus. So, for example, you could have a situation where a point moves in such a way that its distance from a fixed point is equal to its distance from a given line. So what do I mean by that? Basically, let's say there is a line that is given and there is a point that is given somewhere here. This point is given earlier and this line is also given. Line obviously extends. Now, can we find a set of points in the plane which are equidistant from both, right?
Yeah.
This distance is equal to this distance. So this point, another point could be somewhere here where this distance is equal to this distance. Another point could be here where this distance is equal to this distance. You understand what is happening?
Yeah.
A set of points in the plane which are equidistant from both the line and the point. So this type of a curve is known as a parabola. This curve is a parabola. A parabola is such a curve that every point on the parabola is at equal distances from one fixed point. That fixed point is called the focus of the parabola, and one fixed line. That fixed line is called the directrix of the parabola. This line is known as the directrix line. So given, how do you know distance from a point to a line? We have the point to line distance formula, right? Correct.
Correct.
And distance from this point to this point is simple distance formula. So it is possible to calculate both of these distances. In case your point moves in such a way that both of these distances are always equal, what you get is a parabola. So a, a general example would be something like this. So let's say y is equal to mx plus c is the directrix line. The directrix line, and h comma k is the focus point, is the focus. Now we have to find point p x comma y such that distance of x comma y to this line is equal to distance of x comma y to this point, right?
Yeah.
So the equation for us would be, what is the distance of x comma y from this line? We will write it like this: y minus mx minus c mod by root over 1 plus m square. This is the formula. Distance of a point from a line. We put the
Yeah.
point in the line equation, take mod and divide by squares of the coefficients of x and y, right?
Yeah.
Is equal to, this distance should be equal to distance of this point from this point. So that is equal to root over x minus h whole square plus y minus k whole square, right? So in general, you're getting an equation like this. Obviously, we can simplify this and write it as y minus mx minus c whole square is equal to 1 plus m square into x minus h whole square plus y minus k whole square, squaring both sides and all. And again,
Yeah.
we can multiply everything and get it simplified in a way, bring it on one side and stuff. But what you should realize is that eventually you will get an equation which looks like this: ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0. Like, bring everything on one side, this is what will happen, right? There will be
Yeah.
many terms. Yeah, there will be many terms which will all look like a 2-degree general 2-degree equation, right?
Yeah.
You can collect all the terms and all. I want to show one thing here though. I want to worry about the terms which have y square, x square, and xy. Okay, so let's just focus on the coefficients of those terms. So there is one term here that is just simply y square, right?
Yeah.
Correct. And
Yes.
there is one y square term here also, right? So it will be a y square here. So it will be total 1 plus m square into y square on the RHS side, right?
Yeah.
Correct, no? Because there is nothing else that will come with y square, just this thing will be multiplied, right? So what you
And
can,
what about k square?
k is a constant, no? How is k related to y square?
Oh, okay. Okay. Never mind.
K is a point, no?
Yeah. Okay, point.
So this y square goes to the other side, goes to this side, and you can subtract. So you will be left up with m square y square, right?
Yeah.
Okay, so you're left with m square y square. What about x square? So we have 1 plus m square into x square on this side. From here, there will be an x square term here and 1 plus m square into x square. And there is an m square x square term here. So this goes on that side minus m square x square. So you're just left with x square simply, right?
Yes.
So just simply x square is left here. And what about xy term? There is no xy term here. All the terms are either x square, y square, or just x, just y, or just constants, right?
Yeah. Yes.
There is an xy term here. There is minus 2my minus 2mxy, right?
Yes.
Yeah, there is minus 2mxy. So if you bring it to this side again, you get a plus 2mxy, right?
Yeah.
So, okay. So finally, these are the three terms that I wanted to find out. So what you have to realize here is that A is coming out to be 1, B is coming out to be m square, and 2h is coming out to be 2m, right?
Yes.
Other terms I don't care about. What I wanted to show you is that this has happened. So h is equal to m, A is equal to 1, B is equal to m square, right?
Yes.
So you have the relation h square should be equal to AB, or h square minus AB is equal to 0. See, h is m, so h square is m square, and AB is also m square, right?
Yes.
Which means that basically the three terms here can be combined together in a ax plus by sort of whole square sort of situation, right? See, you have
Yeah.
a1, b is m square y square, so you can say that x plus my whole square, right?
Yes.
And that will give you 2mxy, which is what is the third term there, right? 2mxy is the hxy term, right?
Yes.
So here what we have done is we have taken a general equation of a parabola. There was nothing very unique or special about this equation that we tried to derive. We said that a random line y is equal to mx plus c is my directrix, an arbitrary point h comma k is my focus. And what is the equation of a parabola that results from these two? And what we saw here was that whenever you got a parabola equation, after simplification, it will look like a general 2-degree equation like this: 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This 2-degree equation can be a parabola, but there are some special conditions under which it will be a parabola. And the condition is that h square should be equal to ab, right?
Yes.
H square was becoming AB in our random situation that we took. When we took that situation, we didn't do any special conditions. We took it as the most general case, right? So
Yeah.
in that most general case also, H square was being equal to AB. So what you can say is that these three terms are known as the second degree terms, right? Second degree terms. These are first degree terms, these two, and this is 0-degree term, right? The second
Yeah.
degree terms are the ones which have x square or xy or y square. So second degree terms form a perfect square, right? Form a
Yes.
perfect square. By that I mean that it can be written something like root ax plus root by whole square. Then you will get 2 root ab. Xy is the third term, and h square is equal to ab, so this becomes equal to 2hxy, right?
Yes.
So anytime you get a big equation, if you want to figure out whether it's a parabola or not, either you check h square is equal to ab, or you check that second degree terms, means this term, and this term should form a perfect square. Okay. So
Okay.
that is the signal that will tell you that, okay, this is a parabola, right? And what is a parabola? A parabola is locus of a point which is equidistant from another point and another line, equidistant from a fixed point and a given line, right? This fixed point is called focus, the given line is called directrix. Okay.
Okay. Yeah.
So in general, if you see the figure like this, let's say this is my fixed line and this is my fixed point. To connect these two with a perpendicular line, this is supposed to be my focus, this is supposed to be directrix. Connect these two with a perpendicular, so obviously parabola one point will be in the midpoint of these two, right?
Yeah.
Because it's supposed to be equidistant. Now midpoint is fine. Other points, how do we find out? One point would be somewhere here where you are slightly above like this. So this distance is greater than this midpoint. Similarly, this perpendicular is greater length than this, right? And you
Yes.
keep drawing a locus like this, you'll get, where every time you go far away, this distance will be equal to this distance, right? Something like this
Yeah.
is happening. So you're getting a locus which is a open type of a curve. It is going to be open like this, but this is the locus, this is the directrix line, and this is the focus point. This can be also drawn like this. You could also get a parabola like this here, uh, and you could get focus here and directrix here. basically you can see parabolas looking like if you have y and x axis, you could have a parabola like this or a parabola like this. Many types of situations you can see. We will see examples now of that. So the first thing that I want to see is, okay, we know how to recognize a parabola from the most general equation, the equation in 2 degree. However, normally parabola equations are much simpler. Like most cases, you have a simple parabola with a very simple equation. So let's understand that case first, the simple parabola equation, because that is more likely that you will encounter in any exam. So let's think about it. Suppose your focus is the point a comma 0. Okay, focus is a point on the x-axis, a comma 0, right? And suppose your directrix is the line x is equal to minus a, right?
Yes.
So why is this case taken? Because this gives a very simple case where parabola passes through the origin. So focus is taken at a comma 0 and directrix line is at x is equal to minus a, like this, right? So midpoint of that is 0 comma 0, right? So parabola is
Yes.
supposed to be equidistant from these two things, one line and one midpoint. So it should pass through 0 comma 0, right? This is
Yes.
equidistant. So
Yeah.
in general, let p x comma y be a point on the parabola. How do I find the equation of the parabola? I just say that p x comma y will have distance from focus should be equal to distance from directrix. So you'll say distance from focus will be x minus a whole square plus pi square root over that should be equal to distance of p x comma y from the line x is equal to minus a. So let's say p x comma y is somewhere here. You will realize that what is the distance of this point from this line, right? What do you think is
Yes.
the distance? By common sense also you can say, because this distance is a, right? And this distance is x. So the total distance is x plus a, right?
Yes.
Because px comma y is here, that means that distance from origin, this much is x, right? This much is x, so this much is a, so it is total x plus a. Or you could have done it by the normal method with the equation of the line is x plus a is equal to 0. You put this point in this line, you say x plus a mod by root over 1 square plus 0 square, because there is no y, right?
Yes.
So you should get, there also you should get mod of x plus a. So I'm writing the two distances. This is distance to the focus, this is distance to the directrix. Now we'll square it to remove all this. So you'll get this is equal to x plus a whole square. And now you'll get y square is equal to x plus a whole square minus x minus a whole square, which is equal to 4ax, right?
Yeah.
So the standard equation, this is the most common form of the parabola equation that you will see. And your equation will be y square is equal to 4ax, right? So
Yeah.
here in this y square is equal to 4ax, our focus is a comma 0 and our directrix is x is equal to minus a, the line. Okay. And the parabola will be such that it will pass through the origin and it will be like this. This is the parabola equation. So
Yeah.
you can see multiple variations of this also. So for example, this is my y square is equal to 4ax parabola. A comma 0 is my focus, x is equal to minus a is my directrix. If a is positive, if a is positive, then you have focus will be in the first quadrant and parabola will look like this, and directrix will be in this quadrant, right? And if a is negative, if a is negative here, you will get a parabola that looks like this, and focus will be somewhere here and directrix will be this side, right?
Yeah.
Because everything just gets reversed, right? It goes on the other side and this comes on the other side, right?
Yes.
You can also construct a parabola like this. The equation can be x square is equal to 4ay. Instead of y square is equal to 4ax, you can have a situation like this. And here, x and y have gotten interchanged. So here, what you have is the parabola looks like this. And focus will be somewhere here, which will be equal to y is equal to a, not x is equal to a, and directrix will be somewhere here, which will be y is equal to minus a, this line. Okay, so basically
Yeah.
x square is equal to 4ay is this parabola. X square is equal to 4ay is what I have drawn. Y square is equal to 4ax is the standard one, where focus was here and directrix was here, right?
Yeah.
Focus is here and directrix is here. In x square is equal to 4ay, what has happened is I have interchanged x and y, right, in the equation. So your x-axis is taking the role of the y-axis in the previous one. So that is what has happened. So here you can get focus as y is equal to a and directrix as, basically focus is a point. So focus can be written as 0 comma a and directrix will be y is equal to minus a. And in this one, focus is a comma 0 and directrix was x is equal to minus a, right?
Yes.
So that is the basic simple understanding. This is the simplest possible version of the parabola equation. Y square is equal to 4ax. And
Yeah, but I have a question.
Hmm.
So for the distance from the directrix, right?
Hmm.
You wrote it as apps mod a x plus a.
Hmm.
Why would that be? I just want to make sure.
What is the distance of a random point x comma y from the line x is equal to minus a?
Yeah.
So tell me, how will you do this distance?
Well, you use the distance formula.
What is the distance from?
I mean, point
Hmm.
that line formula. What?
Point to line
It's
formula. In that, what do you do? You have, suppose you have a line equation like this.
yeah.
In this line equation, suppose I wanted to find distance of 1 comma 2 from it to this line. I would
Yeah.
have put 1 comma 2 in the line equation, right?
Yes.
And then taken mod and then divided by root over a square plus b square, right?
Yes.
So this is my line equation right now. X plus a is equal to 0, right?
Mm.
And the point is this. So I have to put this in this. What will it be? X plus a mod. Putting x and
Yeah.
y, whatever this is, into this, you will get this only, right?
Yes.
Divided by root over 1 square plus 0 square.
Correct. Yeah. 1 square plus 0 square. Yes.
So that will become just simply mod x plus a, no?
Yes. Mod of course. Okay.
There is another way to think about it also. The other way is to realize that if you have x comma y, what does it mean? X comma y means that this is at a height of y like this and a distance of x like this, right?
Yeah.
This
Yes.
is your origin, right? So if my line was x is equal to minus a, obviously my x is equal to minus a line is a distance shifted this side, right?
Yeah.
This is a
Yes.
distance this side. So the total distance till here is obviously x plus a, right?
Yes. Right.
Because it is x this side and this is a this side. So distance in this is x plus a, right? So
Yes.
the other distance is obvious, the distance from point to a point, that is simple distance formula. So that came out as x minus a whole square plus y minus 0 whole square root. That should be equal to mod of x plus a. When you square it and all, you get the equation y square is equal to 4ax, right?
Yes.
Correct. So that is the parabola equation, and that is the meaning of the parabola, like how you get. In general, you have to realize that right now we are taking a very simple case where focus was a nice point and directrix was a nice line, and that's why we are getting a simple equation, right?
Yes.
In general, I could have a case like this where focus is a random point here and directrix is a random line like this, right? And the parabola could be a equation, could be like this, right?
Yes.
This is a random y is equal to mx plus c is my directrix and random h comma k is my focus, and parabola looks like this, right? Origin is here. So
Yes.
in that case, when the parabola, I mean, there is nothing special about my focus or directrix lines. In that case, the equation of the parabola becomes the 2-degree equation that we talked about earlier, right?
Yes.
Because we have not taken anything special in that 2-degree equation. And how do you recognize that this 2-degree equation is a parabola? You have to have h square should be equal to ab,
Yes.
right?
That's the condition.
Yeah. So in general, your parabolas could be complicated and have a long equation like this. But in most cases, you will see simple equations because you will take nice points for the directrix and the focus, right? So
Yes.
now what we will do is we will just learn one or two basic things about parabola. We know the meaning, we know the definition and all. Now we'll just learn one or two basic things like how to draw a tangent to a parabola and all, and what is the meaning of a line intersecting a parabola and stuff, like basic stuff. And then we'll stop there because I don't think more than that is required. So if you have a parabola like this, let's say you have a parabola like this, and this is a comma 0 is my focus and x is equal to minus a is my directrix. Then what is the condition that the line y is equal to mx plus c is tangent to the parabola, right? It is
Yeah.
possible for a line to be tangent to a parabola. You could have a tangent at some point here, right? So
Yeah.
what is the condition for the line to be tangent to the parabola? We will understand this in the same way that we thought about line tangent to a circle. So when we're discussing line tangent to a circle, we said that, okay, a line could cut the circle, touch the circle, or not intersect, right?
Yeah.
So similarly, a line y is equal to mx plus c could cut the parabola, touch the parabola, or not intersect, right?
Yeah.
So if I want to solve the equation of the parabola with the equation of the line, solve these two equations together, right? Then whatever when I solve, I mean I'm finding the point of intersections, right? If I try to solve the line equation with the parabola, I'm trying to find the points of intersection, right?
Correct.
Basically, like I'm finding points which are common to both the curves, right?
Yeah.
So by solving, what I will do, in order to solve, what I will do is I will put y is equal to mx plus c here. So I will do mx plus c whole square is equal to 4ax. So I'll get m square x square plus c square plus 2mcx is equal to 4ax. So this will become a quadratic in x, and this looks like this: 2mc minus 4ax plus c square is equal to 0. So this will become a quadratic in x, and we can say for sure that this quadratic can have no real roots or two distinct real roots or two equal real roots, right?
Yes.
These are the three cases that can happen. And for these three cases, we will understand it differently. So if there are no real roots for this quadratic, we know that the parabola does not cut the line, right?
Yeah.
The line passes somewhere like this, doesn't even cut the parabola, right? So no real roots are coming, right?
Yes.
For two distinct real roots, we have the situation that okay, a line is passing like this, it is cutting it at 2 points, right?
Yeah.
And for equal roots, the situation must be that only one point it is touching and going, that is the tangent condition, right?
Yes.
Equal roots means the roots are repeated here, so this line is touching the parabola and going. So now if we are doing this equal root situation, so we can just write the condition on the discriminant here, right? We can just say that in order for the equation to have equal roots, we have to have discriminant equal to 0, right?
Yes.
So
Yeah.
discriminant equal to 0 will mean 2mc minus 4a whole square minus 4 into m square into c square is equal to 0, right?
Yeah.
So if you think about this, expand this a little bit, becomes 4m square c square plus 16a square minus 16amc minus 4m square c square is equal to 0. M square c square gets cancelled. You get this. 16a square is equal to 16amc. 16a gets cancelled. This is a. You get a is equal to mc. So c is equal to a by m, right?
Yes.
So for the line y is equal to mx plus c to be tangent to the parabola, c must be equal to a by m, right?
Yeah.
So the equation of tangent to the parabola can be written as to the parabola y square is equal to 4ax can always be written as y is equal to mx plus c, and instead of c I'll write a by m, right?
Right.
So this is a standard equation. Like whenever you want a tangent to a given parabola which looks like this, we can write it as mx plus a by m, y is equal to mx plus a by m. Here m is a slope that can be anything. Like we can define that slope, right?
Yeah.
So for example, we can find a parabola, we can say tangent to a parabola which has slope m is equal to 1, that will be y is equal to x plus a. Slope m is equal to 2, y could be 2x plus a by 2, right?
Yes.
Different types of slope, you can keep getting different tangent equations, right?
Correct.
So this y is equal to mx plus a by m is the tangent to a parabola with a given slope. If you know the slope of the tangent, you write this equation of the tangent, right?
Right.
And what is more important than the result is to realize how we did it. What was the way by which we are solving? We are saying that let's say a random line is cutting the parabola. So we are just going to solve the line and the parabola equation, right?
Right.
And when we solve it, we will substitute either for x or y, something we'll substitute in the other equation, and we'll end up getting a quadratic. Correct?
Right.
And that quadratic, if it has two real and unequal roots, that means it's not a tangent, it is an intersection. And if that quadratic has two real and equal roots, that means it is a tangent, right?
Right.
And if it has no real roots, that means that there is no point of intersection happening, right?
Huh. Right.
So from a quadratic equation, we can obviously figure out how to write the condition for real and equal roots and stuff. That is just the discriminant, right?
Yeah.
So we write that and then we get the equation of the tangent. We get this condition c is equal to a by m, and we get the equation of the tangent y is equal to mx plus a by m.
Okay.
Right?
Yeah, that makes sense.
The other way, one more way we will see. So basically we want to understand tangents in two ways. One way we have just now seen, when slope of the tangent was given to you. Slope of tangent m, suppose, is given. Then obviously parabola is y square is equal to 4ax. Then you don't need to do much. You just need to say y is equal to m into x plus a by m is the tangent, right?
Yeah.
Because m was given to you, so you can easily find it now, right? So the other way to do tangent is if nothing, slope was not given. What was given is I want tangent at some point, right?
Yeah.
I don't care about slope and all. I care about which point I'm making a tangent to. I want tangent at x1, y1 on the parabola, right?
Yes.
So that is a different way to try to think about it. So let's figure out what is the equation of tangent at a fixed point on a parabola. So we have a parabola, we have a point x1 comma y1 on it, and we want equation of tangent there, right? So
Yes.
parabola is y square is equal to 4ax. So first thing we know is that x1 y1 lies on the parabola, right? So we have
Yes.
y1 square should be equal to 4ax1, right?
Yes.
x1 y1 lies on the parabola, so y1 square should be equal to 4ax1, right? Now
Yes.
equation of line passing through x1 y1 is my tangent line, right? This is the line. Obviously
Yes.
there are infinite lines that can pass through x1 y1. We have to select the proper line, right, which is tangent, right?
Yes.
So there are possibility of infinite lines through this. So our equation should be something like this, passing through point this. So m into x minus x1, right? This
Yes.
is the
Correct.
point slope form equation of a line. So what we need is just, can we find the slope, the correct slope, right?
Yes.
So if we know that, then we'll be able to put that in this and get the equation, right? So now to find the correct slope, like in general, the way we do it for finding slope of any curve at a point, we use calculus. You've heard of this, right? Like
Yes.
slope of tangent at a point. The basic
Yes.
way to do slope of tangent at a point is by calculus, and the thing that you do there is uh, you take a derivative. Okay. Have you ever seen any derivatives? No.
No.
Okay, fine. So then I will not use calculus. Derivative method is really easy. So later when we learn calculus, it will become super easy for you to do this. But then we will not do it because we don't know calculus. So what we will do is a slightly more annoying derivation, but we'll see what it means. So, okay. So what I want to understand is, this is my parabola and this is my point P, and this point is x1 comma y1, right? And I want a line that just touches this, right? This is the
Yeah.
tangent line that I want, right? So think about it. If you had some point here and some point here, right? And there was a line joining them, correct?
Yeah.
This would have been a chord type of a line, right? Right.
Yeah.
And slope of this line would have been something, but if you bring your points closer and closer, the slope of the chord line like this will be similar to what should be the slope of the tangent, right?
Yeah.
Like suppose this point Q and this point R are being brought closer and closer to P, right? Correct.
Yeah.
So like if you come very close to P, Q and R are here and here, then this line slope is almost like the tangent slope, no?
Yeah.
So if it is right next to it, then it's almost equal to the slope of the tangent, no?
Mhm.
Right.
Right.
So basically, what we want to do is find the slope of a chord like this, right? And
Yes.
bring Q and R close to P, right?
Yes.
Okay. So what I will do is I will just try to do that in a figure. So let's say you have a parabola like this. Let's say I want it at this point, P x1 comma y1. Okay. I will take a point slightly ahead and a point slightly before, right? P is x1 comma y1, right? And Q is
Yes.
x1 plus h comma whatever is y1. If x, the equation of the parabola is y square is equal to 4ax, so this point will be 4a x1 plus h root, right? You
Yeah.
understand what I'm saying? I'm saying Q is a point that is slightly ahead of P, right? Ahead of
Yeah.
P, how? This is x1, right? P has x coordinate x1. So Q will have x coordinate will be x1 plus h, right?
Yeah.
So y coordinate of Q should be what? It will be on the parabola. So y square should be equal to 4a into x1 plus h, right?
Yes.
So y should be root of 4a into x1 plus h, right?
Yes.
You understand what I'm saying, no? Let's
Huh.
say R is a point that is slightly behind P. So R should be the x coordinate should be x1 minus h, right?
Yes.
So if x coordinate is that, the y coordinate of R should be y square should be equal to 4a into x1 minus h, right?
Yes.
So y coordinate should be root over 4a into x1 minus h, right? Correct.
Correct.
So okay, so now I know at least my P, my Q, and my R. These are the 3 points, right?
Yes.
Correct.
Yeah.
Now what I need is slope of QR line. Slope of QR line first I need, because that is the slope of the chord. Slope of the chord. And let's find the slope of QR line first. So that will be y2 minus y1, which will be 4a root over x1 plus h minus 4a root over x1 minus h by x1 plus h minus x1 minus h, right? So that is 2h,
Yeah.
correct?
Yes.
So this is my slope of QR line. And now what I want to do is bring the points Q and R closer and closer to P, right?
Yeah.
Because if I bring it closer and closer to P, then the slope of the chord QR will become close to the slope of the tangent that we need, right?
Yes.
In order to find slope of tangent line, I need Q and R to be exactly P, right?
Yes.
So basically one way to bring Q and R closer and closer to P is to make H close to 0, right?
Yeah.
If H tends to 0, then Q will also tend to P and R will also tend to P, right?
Yes.
Okay. So what I want to do, this process, what we are doing right now is calculus only. I'm just explaining what it means. Like what we are doing is taking a limiting value of slope of QR as H tends to 0, right? That is what we want to find out, right?
Yes.
Because slope of QR will become close to slope of tangent if your Q and R coincide with P. So basically what I'm explaining to you right now is taking a derivative only. I'm just explaining it in English and with this limiting value and stuff. So like think about it right now. Directly you cannot put H is equal to 0 in this, no? Because there is a denominator of 2H, right?
Yes.
Like if I want to find what happens to the slope of QR as H becomes 0, you cannot do it by just putting H is equal to 0, right?
Yes.
Because if you put H is equal to 0, like it is divide by 0, right?
Yeah. Yeah.
So what we need to do is something cleverer. And what can we do here? Like we need the limiting value of this. So what I will do is look at this expression. It is like 4a x1 plus h minus root over 4a x1 minus h by 2h. And I want to find out the value of this expression as h tends to 0. So what I will do is multiply up and down this expression with its conjugate, the irrational part of it, right? There is an irrational part of it. I will multiply up and down with this 4a x1 plus h plus 4a x1 minus h divided by 2h 4a x1 plus h plus root over 4a x1 minus h. Why am I doing that? Because this doesn't change anything. This is still divide by 1, right? This is 1 only, right?
Yeah.
However, what it does is it simplifies the top part a lot because it is a minus b into a plus b on top, right?
Yeah.
So that is a square minus b square. So it becomes 4a x1 plus h minus 4a x1 minus h, right?
Yes.
Divided by 2h and divided by this thing, this denominator, right? Root
Yeah.
plus root, right? So notice that the top part now 4ax1 and 4ax1 get cancelled, and what you get is 4ah minus minus, so plus 4ah, so 8ah, right?
Yeah.
So what is useful here is that 8ah will 2h will cancel 8ah, right? And you will get
Yeah.
4a left on top, right?
Yes.
So what you get is 4a by root over this plus root over this, right? That is what is left, right?
Yeah.
So we have simplified this expression MQR to look like this. And now notice that now it is very easy to find what happens to this expression as h tends to 0. Because now you can directly put 0 in it, right?
Yeah.
Because there is no divide by 0 or any weirdness happening, right? In order to figure out what happens to this expression as h tends to 0, you can directly put h is equal to 0. What you will get is root 4ax1 plus root 4ax1, right?
Yeah.
So what you will get is 2 times root 4ax1, right? Correct.
Yes.
And
Yeah.
4a by 2 times root 4ax1, right? That is what is coming, right?
Yeah.
This is your MQR as h tends to 0. Now, in imagine earlier P was the point x1 comma y1, where y1 was root 4ax1, right?
Yeah.
P was
Yes.
that middle point, no? x1, y1, right? Where we
Yeah.
want to find the tangent. So this is what 4a by 2y1, right?
Hmm.
So slope of the tangent is 2a by y1, correct?
Correct.
Basically, think about what we have done. We had a we had 3 points. P was this point, Q was this point, R was this point, and P was x1 comma y1, and the curve was y square is equal to 4ax, and we thought of two other points Q and R. We figured out the slope of Q and R, and we said that if Q and R come close to P, which is what happens when H tends to 0, right?
Right.
The slope of M, Q and R is becoming close to 2a by y1, right?
Yeah.
So the slope of the tangent must be the slope of these two lines when the points become very close to P, right? So basically,
Yeah.
we have found the slope of the tangent. The process that we have just now done is the calculus process only. I've just explained it, the derivative process. Like once you know calculus, you will be able to do this in one line instead of all of the effort that we had to put in. So slope of the tangent is now coming at slope of the tangent at P is equal to 2a by y1. And now the equation of the line is obviously y minus y1 is equal to 2a by y1 into x minus x1, right?
Yeah.
This is the equation of the tangent. Now you can simplify this equation by saying y1 minus y1 square is equal to 2ax minus 2ax1, right?
Yeah.
And you
Yeah.
get y1 is equal to 2ax plus y1 square minus
Yeah.
2ax1, right?
Yeah. How is the denominator y1? I thought the denominator was 2 root 4a y1.
This slope you have not understood. It was 2a by root 4a x1, no?
Yeah.
It was 4a by or something 8ah by 2a and stuff.
Yeah, I got that part, but how did you go from 4a root 4x1 to 2a y1 to a y1?
Because x1 y1 is a point on the thing, x1 square 4a x1 is equal to y1 square.
Oh, okay. Yeah.
It's on the curve, no?
Yeah.
So y1, what is y1 square? It is 4ax.
Yes.
Why will I use the root? I will use something simpler. I will write y1
Yeah.
instead of root 4a x1, right?
Yep. Yeah.
This is my equation coming. So this becomes y1 is equal to 2ax and y1 square is equal to 4ax1. So you can put 4ax1 here. So 4ax1 minus 2ax1 becomes plus 2ax1, right?
Yes.
Now you can say y1 is equal to 2a common x plus x1, right?
Yes.
That is my equation of tangent at x1, y1 to the parabola y square is equal to 4ax. So I'll summarize here. So look at the parabola. Y square is equal to 4ax is the parabola. Point is x1, y1. And what we have just now gotten is equation of tangent at that point is coming out to be y1 is equal to 2ax plus x1, right?
Yeah.
Okay. And in the previous class, I had explained to you that whenever you have any arbitrary 2-degree curve, any arbitrary 2-degree curve, whether it is circle, parabola, ellipse, whatever, if you want the tangent at x1 comma y1, there is a nice one line method to get the equation of the tangent. The one line method is coming from calculus, and the way to what you need is at x1, y1, you need a tangent. So what you have to do is replace x square with x1. I told you this replacing method, right? Y square
Yeah.
is y1. Instead of x, I have to put x plus x1 by 2. Instead of y, I have to put y plus y1 by 2. Instead of xy, you have to put x1y plus xy1 by 2. And that's it. Constant remains constant.
Yeah.
This method is valid for all curves, not just for any circle or anything. For any curve, it is true as long as the curve is a 2-degree curve. And this method will give you the tangent equation in one step. Now look at this equation and see that instead of y square, what has happened? Y1, right?
Right.
And instead of x, if you put x plus x1 by 2, you will get 4a by 2, 2a, right?
Yes.
So actually we have derived equation of tangent after so much effort and all, but you could have directly written the answer if you know this thing. Okay.
Yep.
So you should know this thing. This is any curve, 2-degree curve at x1, y1. If you want the tangent, just do these steps. You have to replace x square with x1, y square with y1, x with this, y with this, and constant will not change, and xy with this. If you remember these 5 replacements, then you know the equation of the tangent immediately, right?
Yes.
The method to derive this is by calculus. We'll see that derivation later, right? Not right now. But we have anyway derived this. We have derived this today and by the method of the slope of chord, and we are taking the slope of chord to become tangent, right?
Yep.
The other equation of the tangent here was, if you know the slope of tangent was known, slope of tangent was given m, given to be m, then the equation of the tangent was y is equal to mx plus a by m, right?
Huh.
So
Yes.
these 2 types of tangent equations we have seen today. Nothing much else is needed. Uh, this second type of tangent equation we saw by doing discriminant equal to 0 if y is equal to mx plus c intersects the curve, right?
Yes.
So both of these methods are useful, like because sometimes they might give you draw a tangent at a particular point on the parabola. If they give you the point, then you should use this method, right?
Yeah.
If they give you, okay, a tangent of slope 2 by 3 was drawn to the parabola, then obviously the slope is given, then you should use this equation, right?
Yeah.
So it depends on the problem, how the question is framed and what you need to use. However, we have understood both the methods. Nothing more than this should be required at this stage. Uh, that's all that I wanted to discuss in parabola. The definition, the meaning, what is the locus of a parabola, what is the equation of a parabola going to look like. We saw the simple case where the parabola was y square is equal to 4ax because the point and the line that we chose, the focus and the directrix were really simple, right? A comma 0 and x
Yes.
equal to minus a. The more complicated case could happen when the point is any arbitrary point and the line is also any arbitrary line, right? In
Yes.
that case, we saw that the parabola equation could become a long 2-degree equation, right?
Right.
And if you're given a long 2-degree equation, how will you recognize that it is a parabola? It is if you know that h square should be equal to ab, right?
Yeah.
Or the 2-degree terms in that equation should be a perfect square. Then you can say that that is a parabola, right?
Right.
So go through all of the stuff that we saw. This stuff is there in SL only, but you don't have to read the entire bit. You just refer to what we have discussed so far, and that should be enough for your exam. In the next class, we'll probably do ellipse hyperbola a little bit, or we can even start number theory. It depends. Like I don't know if ellipse hyperbola is so useful for you right now, but
I only have like two and a half weeks left. So I think we should prioritize the important topics. Ellipse and hyperbolas will not come, that's for sure. It's like not AMC level type. So we can get started number 3 and start working on past papers next class.
So number theory we can do. We can do this week's classes. We can do number theory.
Yeah,
So past papers, no theory. Like you don't know the theory here, no.
yeah.
Like past papers, so you can work through and you can find solutions online, but you need to know some basic theorems and all. We can discuss that in the next coming classes.
Okay.
Because right now I don't think you know enough theory for number theory, so we can do that. Once we know a little bit of basics, then we can go ahead and discuss problems after. Okay.
Okay.
So
Yeah.
Wednesday will be the class. Can do this. We'll do this on that day. Okay. That's all for now then. I'll see you.
Okay. Bye.
Bye.